1.2 More concept, empirical and molecular formula. Today we will learn how to determine empirical and molecular formula from the mass composition or combustion data. Calculation of empirical and molecular formula divide by two types. First one is a simple calculation. Look at the question number A. The question is give the 24.27% carbon, 4.07% hydrogen, and 7.65% chlorine. And the question gives you the molar mass and asks about empirical formula and molecular formula. This is a simple calculation because the question already gives the percent of the carbon, hydrogen, and chlorine. Since the sample of carbon, hydrogen, and chlorine given in the percentage, so we can assume mass of sample is 100 gram, meaning that carbon is 24.27 gram, hydrogen is 4.07 gram, and chlorine is 7.65 gram. So we divide the carbon, hydrogen, and chlorine with the molar mass. So this is a mole we get. So after that, we choose which one is the smallest mole. The answer is this one, 2.0183, meaning that to get the smallest mole ratio, we divide the carbon, hydrogen, and chlorine with the smallest mole. So 2.0183. So for hydrogen, we divide by 2.0183. So at the end, we get the simple ratio is 1 to 1. So don't forget to write the answer empirical formula equals to CH2. CH2 and Cl is 1. Second type of method is calculation involve combustion analysis. So this is a method to measure amount of carbon and hydrogen in a sample organic compound. The organic compound can be formed by the carbon, hydrogen, oxygen, nitrogen, or halogen. The concept of the experiment is the sample will combustion with the oxygen and produce carbon dioxide, H2O, and maybe others gas. So the concept is the carbon, sample with the carbon, hydrogen, and another element, so they will combustion to form the product. Okay, the first one is all hydrogen in the sample is converted to H2O. Then the H2O absorbed by the H2O absorber. Second, the gas of CO2 release, where is all carbon in the sample is converted to CO2. So CO2 release and the CO2 were absorbed by the CO2 absorber. Example, NaOH. Let's view the process. Combustion, release, H2O. H2O absorbed by the H2O absorber. We can get the mass of H2O. Then we can get the mass of hydrogen, where the mass of hydrogen is represent mass of the hydrogen in the sample. Okay. Second, when they release the CO2 gas will absorbed by the CO2 absorber. Then we can calculate the mass of CO2 and the mass of carbon, where the mass of carbon is come from the sample here. Meaning that from this process, all carbon convert to CO2, so we can get the mass of carbon from CO2. All hydrogen convert to the H2O, meaning that we can get the mass of the H from H2O. Just now we know mass of carbon is come from CO2 and mass of hydrogen is come from H2O. So how we calculate the mass of carbon and hydrogen in the sample from the CO2 and H2O? So the concept we're using is a mass fraction method. So this is a formula for mass fraction method. So where is the mass of elements equals to the mass of element in the compound over the mass of one more compound times the mass of compound. So how to apply this formula is, example, mass of CO2 is 0.561 gram. So this is mass of compound. So to calculate the mass of element, the element now is referred to the carbon. So mass of carbon equals to the mass of element. Element refer to carbon. So carbon here is a 12. So meaning that is a 12. Then mass of compound. Compound is referred to the CO2. CO2, the mass is a 44. Okay, so meaning that 12 gram for carbon divided by 44 gram of CO2. So times the mass of the compound 0.561 gram. So we'll get the mass of carbon 0.153 gram. So this is a method to calculate the mass of carbon or hydrogen from the CO2 and H2O. So this is an example for the second type of question. First one, this is isopropyl alcohol contain carbon, hydrogen, and oxygen. Combustion with 0.255 grams. So this is sample, mass of sample, and 0.561 gram is mass of CO2. 0.306 gram is H2O. So the question asks to calculate empirical formula and molecular formula with a given molar mass. So we analyze the question. The first one, the sample contains the carbon, hydrogen, oxygen. Combustion with oxygen produce CO2 and H2O. So from the data CO2 and H2O, we can calculate the mass of carbon from CO2, mass of H from H2O, but how about mass of oxygen? So now look at here, sample contain oxygen and the combustion with the A with oxygen, meaning that the oxygen from CO2 and oxygen from H2O maybe come from the A oxygen gas or oxygen in the sample. So we can't calculate the mass of the oxygen from H2O. We can't calculate the oxygen from CO2. So how we get the mass of oxygen? We're using this formula. Mass of oxygen is equals to mass of sample minus the mass of carbon and hydrogen. So this concept students must really understand. So we cannot calculate the mass of the oxygen from H2O. To calculate mass of carbon, we're using the mass of element carbon 12 over the mass of CO2 44 gram times the mass of CO2. So we will get the answer 0.153 gram. But how about mass of the hydrogen from H2O? So hydrogen is a 2 gram. Why 2 gram? Because this is a H2O. 1 times 2. So 1 is molar mass for hydrogen, contain 2. So 2. That's why the answer here is a 2. Divided by molar mass H2O, 18 gram. So times the mass of H2O. So insert the value. So I will get the answer 0.034 gram. So we calculate the mass of oxygen by mass of sample minus the mass of carbon and hydrogen. So I just remind you, we can't calculate the mass of oxygen from CO2 and H2O because the sample contain oxygen and maybe they mix with the A to produce CO2 H2O. So the answer I get is 0.068 gram for oxygen. So you can calculate, you can check the answer 0.255 gram after minus the mass of carbon, hydrogen, the answer must positive value. To calculate the empirical formula and molecular formula, first we do the table, carbon, hydrogen, oxygen with the mass, then we divide by the molar mass, so we get the different ratio. Now we choose the smallest ratio, smallest mole is 0.0425, meaning that to get the mole ratio, we divide all the mole with the 0.00425. So the answer is a 3. For carbon, hydrogen is 8, the oxygen is a 1. So at the end, empirical formula is a C3H8O1. To calculate the molecular formula, we can divide by the molar mass and the molar mass empirical formula. So you get the answer equals to N. So N equals to 2. So that means molecular formula is a C3H8O2, and the final answer is C6H16O2. So you must leave the answer in this form. After we review the two methods for the empirical formula and molecular formula, so now is a keep in mind. So if the mass given in percent, we assume total mass is 100 gram. So let's say 75% carbon equals to 75 gram, 25% hydrogen is 25 gram. The second point is the ratio, mole ratio is not in the whole number. So we must multiply all ratio become whole number. Okay, let's say we get the answer is 1, 1.35, and 1. So we can't assume the answer is 1.0. We can't assume like this. So we must that times multiply some value so that all the mole will get the whole number. So now I times 3, so I get answer 4. So here we get 3, here we get 3. So meaning that the ratio is 3, 4, and 3. So let's say I get the answer is a 1.5. So you come near to 1.0. It's wrong answer. So what you can do it is you can times 2. So you will get answer 3.0. Once you times 2, all the element must times 2. So this is a key in mind for this subtopic. Thank you. Wow,